Hi everyone, let's solve this problem. Partition labels. You are given a string S. We want to partition the string into as many parts as possible so that each letter appears in at most one part. For example, the string ABABCC can be partitioned into ABABCC, but partitions such as ABA and BCC or ABABCC are invalid. Note the partition is done so that after concatenating all the parts in order, the resultant string should be yes. Return the list of integers representing the size of these parts. So this is the major focus which you need to understand. We want to partition the string into as many parts as possible so that each letter appears in at most one part. So let's say, for example, in this particular case, A and B are all occurring in the same string and C are all occurring on the same partition string. If you consider this case, B is present in both the substrings, which is not the right case, and same thing here, A and B are present in two different strings. That's not the valid use case. So let's try to understand the solution with this particular example. So these are the strings and the above are the indexes, and we are going to see how we are going to maintain a map. So for every character we are going to maintain a map, and whatever is the last occurrence of the character we are going to update. So initially we have A, so its occurrence is at 0, B is 1, A is 2, so we will update it, and B is 3 and C is 4, so we don't have C, we are going to update it. B is 5 and A is 6, C is 7, A is 8 and D is, so we got A as last occurrence as 8 and D is 10. So let's first try to track. Okay, let's continue for a few more steps here. E is, I think D is 9 and E is 10 and F is 11 and E is 12 and G is 13 and D is 14 and E is 15 and that is all. So basically we have kind of tracked till here, so this should be good enough for us to understand the solution. We can do further like tracking is not really required here. So initially I will create the entire map along with all this tracking. Okay, let me also create the tracking for the entire part. H is 16, I is 17, J is 18 and H is 19, K is 20, L is 21, I is 22, J is 23. So we have updated all the partitions. Now we will maintain couple of things. So if you observe the result should be, if you get these are the three partitions, we should be returning the length of the each partition in the result, and result will be an array. So we will maintain a result array and we will push our result, and we will maintain a end pointer, and also we will maintain a size pointer which we will be pushing into result. Initially end and size will be 0, and now while I'm iterating A, I will increment my size as 1 because I have seen one character so far within the single partition, and end of A will be coming from this map. End of A is 8, right? And then I will move to B, and the size will be 2 characters I have seen, and now B's end is 5. 5 is less than 8, so we don't really have to update our end. And then I will be moving my A pointer my pointer to A, and the size will be 3, and the A endpoint is already 8, which we have updated, so it will still be 8. And then I have B. When I'm at B, the length will be 4, size will be 4, and B's endpoint is 5. Again, it is less than 8, so we will not be doing anything over there. And then I am at C. C's endpointer is 7, 7 less than 8. Again, it is less than 8, so we will not be updating it. So my size is 5. I have seen 5 characters so far. And then I will move to B. B's endpoint is 5, which is again less than our endpoint, so we will not update it, and we will update our size. And then we will move to A. When we move to A, we have the endpoint as 8, so it's already up to date, we don't really have to update anything. And then I'll move to C. When I move to C, the endpoint is 7 again, less than 8, so we're not going to update that. And we kind of have seen 1 2 3 4 5 6 7 8 characters so far. And then I'll move to 8, and then 8 endpoint is already 8, so we are not going to do anything. But the current index has reached the end index, so we have seen 9 characters, so we are going to push 9 here. So if you see the answer, the first one is 9. Now we are going to again restart our iteration. So now I will have to reset my size to 0. I don't really have to update end pointer, because any which ways it will be updated going forward. So again I will start from here. So I have seen 1 character, and D's end pointer is 14, so it will be updated with 14. Now I will move my pointer, I'll update my size. E's end pointer is 15, so it's greater than 14, so I'll be updating my end pointer. And then I will move to F. I have seen 3 characters, and F's endpoint is 11, which is less than 15, so we are not going to update it. And then I'll move to E. E's endpointer is 15, which we already have up to date, so we are not going to change anything. Then I move to G. So 1 2 3 4 characters I have seen. Now this is the 5th character, and G's endpoint is 13 again, so we are not going to update this because end is 15. And then we see 14. We have seen 6 characters so far. D's endpoint is 14, we are not going to update it. Then I land up to 15. So E is endpointer 15, so we are not going to change anything. And we have seen 7 characters, so this is length 7. This is what we are going to see here. Again, my index is equal to end pointer, so we have pushed our answer. Now we just have to reset our size to 0. When after pushing the result, we will reset our answer to 0, and we again will restart from the next pointer 16. So H end pointer is 19, so we are going to have a 19 pointer. Then we will increment our size, then move to I, and now I's end pointer is 22, so which is greater than 19, so we are updating it. And then J's end pointer is 23, which is greater than this, so I'll be updating it. Then H end point is also, we will be updating this, the size. H end point is 19, which is less than 23, so we are not going to update it. K, we have seen 5 so far. K's end point is 20, which is less than this, so we are not going to update it. And L's end point is 21, which is less than 23, so we are not going to update it, but we are going to increment our size. And then when I am at 8, I, we'll increment the size, and we'll check I's end point is 22, which is less than 23, so we are not going to update it. And J, we are going to increment the size, and we see that end of J is nothing but 23, and also this particular index is equal to the end, so we are going to push the size. So this is how we are going to get the answer. So let's try to write the code for this. And one more thing is that S consists of all lowercase English letters, so it will be only having A to Z small case letters. So we will maintain a last index map, and we will maintain a result which is an array. We will maintain a size of the partition. Initially it is 0, then we'll maintain an n of equal to 0. Then we will iterate over, first we will iterate over all the characters and we will create the map. So this is how we iterate over all the characters, and we are going to s of I equal to the index. So whenever we see the, let's say for example we see A for the first time, the index will be 0, and whenever we see the A for the next time, whatever is at the current index, it will be updated. So this particular map will always contain the character and its last index, and then we will iterate over the letters again. I plus plus. So we will be, whenever we see a character, we are going to increment our size, and end will be always maximum of end comma last index map of s of I, right? If we get a greater index, we will update our end, otherwise we don't update. That's what we were trying to do at this particular position. Now once we get this, if my current index is equal to n, I will push the end into my result, and I'll have to push the size into my result, and I'll make size as 0, and towards the end I will just return the result. I'll just run this code and let's submit it. It is successful. Let's also understand the time and space complexity of this solution. The time complexity is basically big O of n, considering n is the length of the string. N plus n would be big O of n, right? And the space complexity of this solution is big O of one constant time, because we are just using the map which has 26 character A to Z small case, so it would be constant space, and rest all operations are big O of one operation, so it will not account to any time complexity or the space complexity. So I hope the solution is clear. Thank you.